Hello, Royals. Let's talk a little bit about lesson 4.1. I just want to illustrate some of the issues that come up when talking about motion. Let's say that we have an object and it's traveling in one dimension and it's moving to the right. Is it getting closer to the origin or further than the origin? You don't really know because you don't know where the origin is. Is it to the left of the origin or is it to the right of the origin? So you can't just use an object's velocity to determine whether it is getting closer to the origin or further from the origin. If I give you an object and say, here's the origin and the object's right here, is it getting closer from to the origin or further from the origin? Again, you don't know. You can't just use the displacement. You have to use two of these facts. And the four situations that I asked you to illustrate in the lesson included, I think we started with the left. So let's just start over. Um, Four situations I asked you to illustrate. Imagine an object that is to the left of the origin, moving left. To the left of the origin, moving right. To the right of the origin, moving left. Or to the right of the origin, moving right. This object is getting further away from the origin, getting closer to the origin, getting closer to the origin, and getting further from the origin. That's how we discovered the relationship between the signs of the displacement function and the velocity function. Same thing for acceleration and speeding up versus slowing down. It's a very common mistake for students to think that if the acceleration is positive, the object is speeding up. If the acceleration is negative, the object is slowing down. And I'm gonna switch to a vertical analogy here and use a very popular negative acceleration, and that is one of an object accelerating downwards towards the Earth. So here's the surface of the Earth, and here's a ball that's thrown in the air. The entire time during this pathway, its acceleration is negative. That does not mean that the object is slowing down. After release, the object is slowing down, and then when it gets to its apex here, the object is stationary. But then, if I just release this pen, I know I get that this is a terrible perspective with this top-down camera, but I'm not going to move this thing. I release this pen, it's speeding up. It was stationary when I held it. It was moving the fastest when it hit. This is because conversations about moving fastest are scalar conversations, not vector conversations. So in during this portion of the object's path, its velocity is positive, but its acceleration is negative, and that's why the object is slowing down over that interval. During this portion of the object's path, the velocity is negative and the acceleration is negative, and that's why the object is said to be speeding up. Use some students find it possible to look at just the original curve and determine when an object is speeding up or slowing down. They recognize that this relates to steepness, not slope, but the steepness of a curve. When a curve is getting steeper, a displacement curve is getting steeper, that means that the object is speeding up. That can be difficult to communicate though. Generally, I give you the directions to justify with a factor interval chart. All right. Last thing to mention is do make sure, like in the lesson, that your conclusions are written in English with units, not in interval notation. Try that out.